Hey guys, so we are going to finish up lesson 5.5, work on the even problems that we skipped over the other day. I am going to be moving a little bit more quickly since I, explained the concepts in yesterday's lesson, but this will just be for extra practice for you. So feel free to first do the problems on your own and then just watch the video lesson to, sorry, I'm trying to figure out which screen to present to see if you know what you're doing. Or you can work along with me if you still need some extra help. Okay. So today we're working on the evens. So that's going to be 2, 4, 6, and 8. So just 4 quick problems to work through. Actually, let me go like this. Give ourselves more room. 2, 4, and then 6 and 8 will be the problems that we work on. So let me get rid of those. All right. So the first problem, we're going to first do f plus g of x and then f minus g of x, evaluate both at -1 and talk about the domain. Okay, so f plus g of x, I'm going to take the f of x function, negative x squared minus 3x plus 8, and I'm going to add to it the g of x function, which is 6x minus 3x squared. All right, so combining like terms, first, I'm going to have -1 minus 3 is a -4x squared. -3 plus 6 is a positive 3x, and then plus 8. Okay? And your domain for this problem, look at the original. You can square any number. You can multiply any number by 3. You can multiply any number by 6. You can square any number, so it's all real numbers. All right? Now for f plus g of -1. You have -4 times -1 squared plus 3 times -1 plus 8. So you have -4 times 1 minus 3 plus 8. So you have -4 minus 3 plus 8. -7 plus 8. It's a positive 1. All right. All right, let's try the next one, which is f minus g of x. So f minus g of x. For this one, don't forget to put the g of x in parentheses. So it's -x squared minus 3x plus 8 minus parentheses 6x minus 3x squared. The parentheses are super important so that you remember to distribute that negative, change signs of everything in the second set of parentheses. So minus 6x plus 3x squared. Now combine like terms. So f minus g of x, -x plus 3x squared is going to be just a 2x squared. Then I have -3 and -6, so it's -9x, and then a plus 8. Your domain is still all real numbers. All right. And then f minus g of x, or of, -1. So substitute a -1 in now for all the x's. So I have -1 squared, which is 1, times 2 is 2. -9 times -1 is a positive 9, plus 8. 9 plus 2 is 11. 11 plus 8 will give you 19. 19. All right. So that is problem number 2. Problem number 4. All right, so for problem number 4, same process, same setup. We're first going to do f plus g of x. So I have 5 times the 4th root of x plus 1 plus -3 times the 4th root of x. All right, so these are like terms, like radicals, right? Same index, same radicand. So you work with the coefficients. 5 minus 3 is 2 times the 4th root of x, and then you still have that plus 1, okay? And that is your function. F plus g of x equals 2 times the 4th root of x plus 1. You have to look back at the original problem to think about the domain. The 4th root, okay, since it's an even index, you only want 0 and positives. You don't want negative. So x has to be greater than or equal to 0 here. Same thing, 4th root. So x has to be greater than or equal to 0 here. And in the final, x has to be greater than or equal to 0. So the domain is that x has to be greater than or equal to 0. All right. And then we still have to evaluate f plus g of 1. So I have 2 times the 4th root of 1 plus 1. The 4th root of 1 is just 1. 1 times 2 is 2. And then 2 plus 1 is a 3. Wait, why did I not get that same answer before? Did I make a copy error? No, that's plus plus. Nope, I have an error in my notes, I believe. Plus, right? It's a plus there. Okay, because for some reason in my notes I subtracted 1. Not sure why. I think that's just an error on my part. Okay. All right, so now let's do f minus g of x. F minus g of x. So I have 5 4th root of x plus 1 minus negative 3 4th root of x. Clean up the sign. So it's 5 4th root of x plus 1 plus 3 4th root of x. Like radicals, so you add their coefficients, it's going to be 8 4th root of x plus 1. So your f minus g of x function is equal to 8 4th root of x plus 1. Why do I have a plus 3? Hold on a second. Oh, you know why? I'm not copying down. I did not see this minus 2. That's why my notes are different than my answer key. I didn't copy that down in the last problem. So if you guys copied that down, you probably have a different function than I did and a different evaluation for g of x. So let me fix this one because I made a mistake. Okay. I just didn't copy the whole problem down, that's all. So it's minus negative 4th root of x minus 2. So distribute the negative in, right? So let me go back here. So it becomes, well, if I distribute, it becomes a positive. Distribute becomes a positive. Now, like terms, 5 plus 3 is 8 4th root of x, and 1 plus 2 is a plus 3. There we go. Now my answer key matches what I'm writing here. Okay, and evaluating at 1. So I have 8 times the 4th root of 1 plus 3. So the 4th root of 1 is 1 times 8 is 8. And then 8 plus 3 is going to give you an 11. Okay, I didn't talk about the domain up here. For the domain, you can't take a cube root of a negative. So x has to be greater than or equal to 0. X has to be greater than or equal to 0. X has to be greater than or equal to 0. Okay, so this is correct. If I just go back for just a quick second, in case you actually copied the problem down correctly in the last one when I did f plus g of x, I'm going to just jot down the correct answer because, again, I did not, for some reason, when copying the problem down, see this minus 2. So if you do it correctly, you should get 2 4th root of x minus 1 because it's a 2 I didn't have. Again, I didn't have that copied down the first time. And then the domain is still x has to be greater than or equal to 0. And then the evaluation, I forget what I had, plus g of 1. The evaluation would have been a 1. Okay, so I just wanted to clear that up in case you copied the whole problem correctly, which I didn't. All right, 2 more to do. Number 6. So now we're going to multiply and then we're going to divide. Okay, so multiplying first, f times g of x. So we have the f of x function is 12x. The g of x function is 11x to the 1/2. You can multiply in any order. So if you want to rewrite it as 12 times 11 times x to the 1/2, just so everything is next to, what it's going to be multiplied by. All right. So when multiplying, you can, same bases here, right? Excuse me for just a second. All right, sorry about that. Okay, so same basis here means you're going to add the exponents, and then we have to multiply. So 12 times 11 will give you 132. and then x to the 1 plus 1/2. So you have 132, and then you're going to add 1 plus 1/2, which is 1.5 or 3/2. Okay, so your f of g of x function is equal to 132 x to the 3/2. Your domain for this problem. All right, up at the original, you can multiply any number by 12. So any number can get plugged in for x here. Over here, you can only take the square root of 0 and positive numbers. So right now, your domain is x has to be greater than or equal to 0. And down here as well is a square root. So x has to be greater than or equal to 0. Okay. The last part of this problem, f of g of 4. So you have 132 times 4 raised to the 3 over 2. So if you want to rewrite that, that's 132 times the square root of 4 and then cubed. 132, the square root of 4 is 2. And then 2 cubed is 8. And then 132 times 8 gives you 1,056. All right. Now let's do f divided by g of x. F divided by g of x. So you have 12x over 11x to the 1/2. So you can break this up as 12 over 11 times x over x to the 1/2. All right, the 12 over 11 is not going to change. But here, same base to exponent rules to subtract. So 1 minus 1/2. So that's going to give you 12 over 11 x to the 1/2. If you want to put the numerator or the variable up in the numerator, you can. So you can write it just like this, how I left it. Or you could write it as 12x to the 1/2 over 11. Okay, now the domain. Now this is where I forgot with the problem from yesterday's lesson. At the original, you can multiply any number by x, that's fine. Here, you can only take the square root of 0 and positive numbers. So far, I'd say the domain is x has to be greater than or equal to 0. But then look at the setup. You cannot have a 0 in the denominator of the fraction. So if you plugged in a 0 for x, you'd have a 0 in the denominator. You can't do that. So x has to be greater than 0. Okay? So that's your domain. And then finally, f of g of 4. So you're going to have 12 times 4 to the 1/2, or square root of 4, over 11. So you have 12 times the square root of 4 is 2 over 11. 12 times 2 is 24 over 11. Okay. And the last problem. All right, so we're going to start with f of g of x is equal to 36x to the 7/4 times 4x to the 1/2. Again, rearrange 36 times 4 times x to the 7/4 times x to the 1/2. You're going to multiply 36 times 4 to get 144. And then you're going to add 7 over 4 plus 1/2. If you want to get common denominators, you're going to change that into 2/4 instead of 1/2. So it's 144x 7/8 Right, so that's your f of g, f of g of x function. F times g of x function. All right, the domain. So fourth root, you can only take the fourth root of positives and 0. Square root can only take the square root of positives and 0. So the domain is x has to be greater than or equal to 0. Can't have negative numbers for this function. All right, and then f times g of 16. So it's going to be 144 times 16 raised to 9/4. So you're going to take the fourth root of 16 All right, that's 2, and then 2 to the ninth. That's 512, right? 4 through 16, 2 to the ninth is 512, and then times 144. All right, so again, I'll write that out in case I lost you. I had to type it into my calculator though. So the 4 through to 16, and then raise that to the ninth. So it was 2 to the ninth, 2 to the ninth, which is 512, and then 512 times 144 is 73,728. Last part is the division. F divided by G of X is equal to, so you have 36 x to the 7/4 divided by 4 x to the 1/2. You can break that into 36 over 4 and then times x to the 7/4 over x to the 1/2. 36 divided by 4 is going to give you 9. And then same base, subtract exponents, x to the 7/4 minus 1/2. Get common denominators. So it's going to be 7/4 minus 2 minus 2/4. So you're going to have 5/4. Okay, so f of g of x is equal to 9. Oh, I forgot my variable. Like, where did my variable go? 9 times x to the 5/4. Okay, now your domain. Looking back at the original, x has to be greater than or equal to 0 here. X has to be greater than or equal to 0 here. But look at, especially with the divisions, don't forget to look at the setup. X cannot equal 0 because if you put a 0 in here, you're going to have a 0 in your denominator, which you can't divide by 0. So x has to be greater than 0, not greater than or equal to 0, but greater than 0. Okay, so there's your function, there's your domain. Last step is evaluating the function when x is equal to 16. So you have 9 times 16 raised to the 5/4. So rewrite that as the 4th root of 16 and then raised to the 5th. So you're going to have 9 and then 2 raised to the 5th. 2 raised to the 5th should be 32. And then 32 times 9 is going to give you 288. So 32, and then that's 288. Oh, 88. All right, guys, hopefully between yesterday and today, you're understanding how to add, subtract, multiply, divide functions, how to evaluate them given a value, and then also how to state the domain. All right, that's it for lesson 5.5. I'll see you back here for the next one. Bye.